Hello guys, it is September 22nd. You hopefully watched that little video on the gallium. I think it's a really cool kind of metal to have in hand. It's very inexpensive too. You can buy it on Amazon. I wouldn't recommend it for younger kids to play with. So if it's something you want to purchase, it is purchasable. It's like $10 or less, and it's a really cool thing to work with. What I love is that it becomes totally liquid at like 80 something degrees Celsius. Well, our natural body temperature is 98.6. So if you could get that whole clump and lie it here, it would automatically start melting just while you held it, which I think is a really cool kind of thing. So that's why I linked it up, just for the cool factor. And it was talked about on page 374 in the text feature that was there. So just kind of wanted to give you like a visual of it. All right, so today you're gonna need your journals again for today. We are going to be looking at creating two flow charts today. And we are going to be looking at a flow chart of heat added and heat taken away. And what does that look like? So when you add heat to something, how does it go through those states of matter as heat is added? And then how do those states of matter change as heat is removed? Okay, so I like to think about ice, and that's kind of where we're going to start. Okay, so got to find a marker that's kind of bright. So our first flow chart is going to be titled heat added. Okay, heat added. Now, we're going to go ahead and we're going to make rectangles. We're going to list a solid. We're going to make another rectangle. And we're going to say a liquid. Because we already knew we're going to talk about them in relation to the states of matter. And we know our states of matter, the three that we're going to be talking about today, is a solid, a liquid, and a gas. So if I think about ice as a solid, and this is kind of what it helps me. I can say that I have ice as a solid, and when I add my heat, ice will turn into what? Exactly, it's going to turn into water. Because this flow chart is all about heat added. So ice is a solid. When you add heat to ice, it turns into a water. When you've got your water and you continue to add that heat, what happens to your water? It's going to boil. You're going to have the smoky things come up off the pan and off the water. And what do we call that? Steam. Steam is a gas. So we've got ice. Ice turns into water. Water turns into steam. Now, these are two flow charts, and they are what I like to call a reverse flow chart. So now I got to think about if I take heat away. Now, if I take heat away, and I'm still thinking about that ice situation, and I'm going to go ahead and I'm going to make my boxes. I'm going to take heat away. And I'm kind of going to draw an arrow up there because I'm going to start with now steam, okay? Because I'm still following that water, ice, steam kind of scenario. So I'm going to start with steam. If I take, and we said that steam is a what? It's a gas. So I'm going to start with a gas. As that steam, that cloud of steam that's coming up, as it cools, as heat is taken away, what happens to that steam? What happens to it? It's going to turn back into a liquid. As steam cools, then it goes back to a liquid state. Now, does that mean when I've gone out to my garden and I've picked me a whole mess, as my mama would say, I picked a mess of green beans to cook, and I've broken them up, I've washed them off, I put them in my pot, and that mess of green beans is going to require me to cook them for a couple of hours before I can have them for dinner. As the water in my green beans heat up, the beans will start to boil. That boiling will produce steam, and that steam is going to collect on my cabinetry. Now, as the heat is gone away from the pot, that smoky stuff will collect on my cabinets and turn into water droplets. That's the liquid I'm talking about. Now, if I took my, say, a paper towel, and I wiped all the water droplets off the cabinetry, and I wrung it out into a glass, and I continue to take heat away, and what could happen? The probability is if I take that and I set it in my freezer, it's going to turn back into a solid, and that solid would be an ice cube. So we got liquid here that's going to be our water, and then we have here our ice again, and then we've got our solid. So if we think about these two particular flow charts and we think about them as they reverse, heat added, heat taken away, and you can keep that visual of ice in your mind, it does help you remember how they flow, okay? Now, one of the things that I want us to talk about is that condensation is one of the big things that was on page 375, where it talked about where things gain enough heat to change into a gas. Let me grab this real quick. Every student that I had last year knows that I use this little McDonald's Cozy every single day. It's in a lot of my videos that I make. It's just part of what I use. The reason that I use it is because of condensation. Without this little Cozy, if I set my drink cup out, and this is almost always, it starts with unsweet tea and it ends up with ice water. And if I set it on my desktop, my rolly desk, or wherever I'm at, and it sits out into the regular air for an extended point of time, I'll start getting that wetness that collects on the side of the cup. Those water droplets are called condensation. It's where the liquid is colder on the outside than the room temperature is on the outside. It's colder on the inside than the air temperature is on the outside. And as they try to regulate each other, it produces that condensation, that wetness. And if I just set it on a tabletop, if I set it on a book, that water will start to drip down and collect around my table's edge. So by putting it in the Cozy, it slows down that condensation process. Doesn't mean it stops it completely, but however, the Cozy itself then collects the water. So condensation is just another piece of that energy transferring. It's a different type of energy transfer. So this is our 2 flowcharts for today. I will tell you, you need to put those in your journals because they are testable items as well. And we are getting really close to a test, guys. I mean, I'm looking at a lesson for tomorrow, which might go into 2 days, and then review and then test. So just giving you a heads up. All right, talk to you later.